Hello guys, welcome back to TechNTechie and to our video on AWS Automatic Load Balancer. In this video, we will explore how ALB can enhance the availability, scalability and performance of your applications. We will start by creating 3 instances and then proceed to set up an ALB to distribute traffic among them. Let's get started. Before we dive into ALB, let's understand the importance of load balancing. Load balancing evenly distributes incoming network traffic across multiple servers or instances. This ensures optimal resource utilization, improves fault tolerance, and enhances the overall performance of your applications. Application Load Balancer is a fully managed service that extends AWS infrastructure and services. Load balancing offers several benefits, such as improved fault tolerance, increased availability, and enhanced scalability. AWS provides the automatic load balancer service, which simplifies the load balancing setup and configuration process. The automatic load balancer on AWS is a highly scalable load balancing service that can handle millions of requests per second. It works at the application layer 7 of the OSI model, allowing it to intelligently route traffic based on various factors. ALB comes with a range of powerful features. It supports content-based routing, enabling you to direct traffic to different backend services based on the requested path or host. ALB also provides built-in support for SSL TLS termination, reducing the load on backend instances. Setting up an ALB involves a few simple steps. First, you need to create a target group which defines the backend instances that will receive traffic. Then you create the load balancer itself, specifying the subnets and security groups. Finally, you configure the listener to define how the ALB should route incoming requests. To demonstrate the power of ALB, we will create 3 instances that will serve as our backend servers. These instances will host our application and handle incoming traffic. We will navigate to the AWS Management Console and select the EC2 service. From there, we will click on Launch Instance to start the instance creation process. We will name it Linux 1 and on the right side enter the number of instances. Here I will go for 3 instances to practice a load balancer. We will choose here Amazon Linux AMI as it is free to use. We will choose 64-bit architecture and instance type would be t2.macro as this also in free tier eligible. We can select key pair here if you already have it. If not, then create a new key pair. Under network settings, we will go with default VPC and select the existing security group if you have it. Otherwise, you can create a new one. The storage will remain as it is because I would like to stick with free tier only. We will not do any changes below to this. Just scroll down to bottom and here we'll add EC2 user data. I have copied and pasted here. Now we can go for launch the instance here. We have successfully launched here 3 instances. Click on instance to see the status. It is showing pending instance state. We need to rename here these 3 instances, so we'll do this first. As we already have Linux 1, so we'll go to rename this as Linux 2 and the third one is Linux 3. Sorry, this should be Linux 2. And the status is now with running. Great. Now copy the public IP address and paste it to new tab. Do the same for Linux 2 and 3. As you can see here, it is showing the site can't be reached. The reason is because we haven't created a new security group for this yet. So we'll do it now. Just click on security group. As you can see, it is launch wizard 1 for me here. We will go for inbound rule to edit it. As you can see here, it is only SSH rule created. We need to create one more rule here for HTTP and the source can be anywhere and we'll save this rule. Now we have to reload these all pages one by one to see that's working or not. Yes, it is working now. You can see now the hello world from a specific IP address. As you can see here, we can access these three instances from three different URL, right? But as we want these all to be accessed from one URL only, then we have to create a load balance. We will navigate to the AWS Management Console and select the EC2 service. As we are already there, so we will click on Load Balancer and then create Load Balancer. Here on this page, we will see four types of load balancer. That is application load balancer, network load balancer, gateway load balancer, and classic load balancer. As this classic load balancer has been retired on August 15, 2022, so we'll leave it. We will talk about the ALB on this video. Application load balancer. ALB operates at the application layer 7 of the OSI model and provides advanced features for modern web application. It supports routing based on the content of the HTTP, HTTPS request, path-based routing, and host-based routing. ALB can distribute traffic to multiple targets such as EC2 instances, containers, IP addresses, or Lambda functions. It supports features like SSL TLS termination, sticky sessions, and advanced request routing rules. ALB also integrates with other AWS services like AWS Certificate Manager and AWS Web Application Firewall, and that is WAF, for enhanced security. Now we'll see use cases. Web application with HTTP HTTPS traffic. Microservices architectures with containerized applications, routing based on URL path or host names, support for WebSockets, HTTP version 2 and gRPC protocols. In the ALB creation wizard, we will configure the basic settings such as the name, scheme, which can be internet facing or internal, and IP address type. I will name it as first ALB. We'll leave this with internet facing and the IP address type should be IP version 4. In network mapping, we'll select the default VPC, and for mappings we need to select at least 2 availability zones and 1 subnet per zone. The load balancer routes traffic to target in these availability zones only. We can select all these 3 availability zones here. We will select now the created security group and remove the default one from here. Next, we will configure the listeners for our ALB. Listeners determine how traffic is routed to our instances based on protocols and ports. We will define a target group for our instances. The target group allows the ALB to know where to route traffic. We will select our 3 instances as target for the group, name this target as first TG, and check all of the settings: protocol, port, VPC, and protocol version, health check settings with success code, and all. Then click on next to register the target group. Select all these available instances to register. Click on include as pending below to see those all in review targets section. Now here you can see the health status is pending, but these are with running state. We need to just click on create target to complete this. Here it is successfully created, but still unhealthy as the target group is not associated, or can say not configured to receive traffic from the load balancer. No problem, we can do it right now. Go back in EC2 Management Console on Load Balancer page to add the target group. As you can see here, it is not yet displayed, so we just need to refresh it. You can see now the first TG or target group. Click to select it as a target group. Finally, we will review the ALB configuration summary and click create to create the load balancer, and then view the load balancer. You can see here the state with provisioning. Till then we can copy the DNS or DNS URL and paste it on new tab. The site can't be reached, and this is because these are still initializing. As we can see this in health status. We need to wait for some time to get our first ALB active, then and then only the health status will be healthy. All good now. We will try to reload this to get the page status. Okay, perfect. It is working now and can see from the single URL. We can see all three instances with three different IP address are communicating successfully. As you can see, these three different URL also working, but we would like to configure only one single URL which can communicate to all these instances from our automatic load balancer. So how would we do it? Let's see it. Scroll down to get the security group. Click on edit security group to see which security group we have and which one we can modify. On this video we have launch wizard 1 security group, so we'll click on it to get it on a new tab. Go to inbound rules and edit it. As we have a rule for HTTP which can be communicated from anywhere, we need to have one new security group, and that group we can add it on source. So only from that security group can be accessed to HTTP. Delete this one and add HTTP rule for inbound for source, which is not here. So we need to create a new security group, then only it can be shown here. Click on security group to create a new one. Name this demo LBS group. Give the description as demo LB and add the rule for HTTP here. The protocol and the port range should be as it is default. Then source can access from anywhere, and now click on create security group. Now come back on previous security group, that is launch wizard 1. Edit it to delete the HTTP rule which can access from anywhere. We need to add here the newly created security group which is demo LBS group. Now we can test the URL again. First we will check these all different URL. Yes, it is taking time to loading, which means it is not accessible. We will see this our first ALB URL as well. Oh, this is also taking time to load. Might be there is some problem with the security group. Let's see what we have done wrong. Come back to first ALB page. Click here on security groups to check all these settings. Right. As you can see guys, it is set to launch wizard 1 security group. We need to select the demo LB. From this security group only the ALB can be communicated. So we'll select the demo LB security group instead of launch wizard 1 and save it. Come back to our ALB URL and reload it. Yes, it is working now. Let me show you again how it works. Go back to previous security group settings and check again this ALB URL. See, it is loading only, taking time to load, and finally it will show this site can't be reached. And all these three individual URL also not working. This is good, this wouldn't work. Now go back to our security group which is demo LB. Choose this one and save it. Reload this page and see it is working again. After reload the page, it shows the different IP. So many times we will reload the different IP address will communicate to this ALB URL. See one more time, these all three individual URLs are not working, which we would like to see. Awesome. ALB target group attribute are configuration that you can set for individual target group associated with your ALB. This attribute defines how the ALB distributes traffic to the registered target within a target group. Let's explore some of the commonly used ALB target group attributes. Go back to our first ALB page and go on Action tab. Click on it to get Edit Target Group Attributes. Leave all of the settings as it is. Just scroll down a little bit to Target Selection Configuration. Here we just need to enable the stickiness, which enables the ALB to bind a user session to a specific target within a target group for a specified duration. With stickiness enabled, subsequent requests from the same user will be directed to the same target, enhancing sessions persistence. This attribute is useful for applications that require maintaining user-specific states or sessions. We will select the load balancer, generated cookie, the stickiness type, and the stickiness durations will be 1 day. Finally, click on Save Changes to save the settings. It has been successfully created. Now reload the ALB URL page to check the status. Yes, this is working. As you can see, after reload multiple times, it is stick to one IP only, as this IP address is saved in cookies for 1 day. After 1 day, when request comes from the requesters, then it will route to another available IP address. Now we will try to remove the stickiness and see the changes applied. Let's wait for some time to get the changes applied. Reload it now. Yeah, that's good. Can see the another IP address now which is communicating to this ALB URL. Perfect. In this video, we explored the power of AWS Automatic Load Balancer. We started by creating 3 instances to host our applications and then set up an ALB to distribute traffic among them. ALB ensures high availability, scalability, and performance for our applications. Load balancing is a critical component of modern application architectures, and ALB provides advanced features and flexibility to handle high volumes of traffic effectively. Thank you for watching. If you found this video helpful, please like, share, and subscribe to our channel for more exciting content on AWS and cloud computing. Until next time, keep exploring the world of AWS and happy load balancing with ALB.